In this third part of our video, we're going to continue where we had left off in part 2, where we had computed the individual deviation scores of each of the 9 test takers from the average. But what we see here that when we calculated the sum, when we added up all of the deviation scores, it led us to what is known as the zero sum problem in trying to come up with a value to describe the distribution of a set of data. And this value is pretty close to zero, and for all intents and purposes we can assume this is zero, giving rise to that zero sum problem. But when we go up to our conceptual equation, we have a squared value for that deviation, and the squared value will address the zero sum problem by eliminating the negative sign in these deviations. So I'm going to create another heading here, and I'm going to label this deviation 2. I'm going to go to the formula bar. I'm going to highlight the 2, and I'm going to hit the bottom right hand corner of our font menu, and I'm going to superscript this. Now generally when working with spreadsheets and giving labels, special characters and superscripts are often not recommended. However, for this purpose, as I'm working entirely contained inside Microsoft Excel, and I'm not going to be converting this for use into another software package, I use special characters, colors, and bolded font to make a visual distinction for what I'm attempting to do here. So what this is telling me to do is to take this deviation value and multiply it by itself. In other words, I'm going to square this value. So I'm going to put that value right here, and I start with the equal sign. I click the cell that contains the value I wish to square, and I shift 6 for this character, and I hit the number 2. And what this character does in Microsoft Excel is this instructs Microsoft Excel to raise whatever value is contained in C2 to the power of whatever number I type in here. In this case, it happens to be a 2, and I hit enter. And I come back up to D2, and I find that bottom right hand corner where my cursor changes to a plus sign, and I'll pull it down across all the raw data, and we see that the negative values have disappeared, and we have these considerably larger values for the squared deviation as compared to the deviation value. And the last step here is to add all these numbers up, because coming back to our conceptual equation in the numerator, we see that the summation symbol says that we have to sum all the squares, giving rise to the label sum of squares for all of these added values. So I can retype in the Excel function, but recall under the deviation column I had calculated a summed value over these numbers. So I can just quickly grab that bottom right hand corner, pull it over, and I'm going to bold this and give it another distinctive color here. So the 156.8 repeated is our numerator for our sum of squares. And our last step here is to calculate, and I'll enter in another column heading, is the variance, which is the left hand side of this equation. And I need to divide the sum of squares, which is our numerator, that's what we calculated here, by the degrees of freedom. And this video started by indicating the degrees of freedom, or rather part 2 started with putting the degrees of freedom. So now I just need to type in the equal sign. I find my sum of squares, so I click this cell, which is D11. I hit the /, and now I look for the degree of freedom value, which I'd put into this cell down here, and I hit enter. And we have a variance of 19.61 repeated, but now we need to put our variance back into the original units for the midterm exam, which is points. Our variance unit will be points squared, which doesn't make sense. However, that's the process to estimate a value that describes the variability among the 9 test takers. So I'm going to create one more column here, one more column heading, and that's SD for the standard deviation. And I'm going to hit the equal sign. Now, if we look at our images here, we had just calculated the variance, and to get back to our original units of points, we just simply take the square root of both sides. When we take the square root of s squared, the square root symbol and the 2 go away, and we're left with the standard deviation of our around our raw scores of x, and we just need to compute the square root of what we had just calculated as the variance. So I'm going to ask Excel to do this, and I'm going to go SQRT, which is the Excel function for calculating the square root of shift 9, open parenthesis, and now Excel's looking for a number to calculate the square root. So I'll just click this value, or this cell rather, which is E2. I'll close the parenthesis with a shift 0, and I hit enter, and we see that our manually calculated standard deviation comes up to 4.428, which is the same value returned when we use the embedded Excel function for a sample of 4.428. One more step here to calculate the standard deviation very quickly. Another way to calculate the square root of this value as opposed to using the Excel function is I'll hit the equal sign. I'll click this value, the variance, and then I'm going to raise that value to the power of 0.5 or 1/2. So I shift 6 and I type in 0.5, and that is equivalent to typing in, or that will have the same effect as typing in the square root function instruction for Excel. I hit enter, and we see that we have the same value for the standard deviation when we use the square root function, which is the same value when we calculated standard deviation by using the embedded Excel instruction or the Excel function. So this ends our third and final video on how to use Microsoft Excel to calculate standard deviation.